Alright guys, welcome back, and we're going to be looking at a couple of things today. The first thing we're going to look at is going to be types of matrices. Now this is pretty short, but let's run through this now. In the previous lesson we looked at defining a matrix and, more importantly, the order of a matrix. So the order of a matrix is going to be highlighted here again. Now the first type of matrix that we want to look at is a row matrix. Now, in order for a matrix to be a row matrix, it just has to have one row. That's it. It doesn't matter how many columns it has, it just has to have one row. So, for example, if we have a matrix looking like this, that's simply a row matrix because it has one row. It has actually 3 columns, but the fact that it only has one row makes it a row matrix. By the way, this matrix here would be a 1 by 3 because it has one row and 3 columns. So in order for a matrix to be classified as a row matrix, it just simply has to have one row. So here's another example. So let's call this example 1, example 2. So here's another example. Very simple. The order of this matrix is 1 by 2. Again, it has one row, so it's classified as a row matrix. So, in order for a matrix to be classified as a row matrix, it simply needs to have one row. Okay, now let's move on. Now, what if I wrote this on the paper? Second type of matrix, a column matrix. Now, what do you think about that one? Now, if you're following suit, then a column matrix is only going to have one column. So, for example, this matrix here. Now, if you notice, it has 2 rows, but the fact that it only has one column, this is a 2 by 1, the fact that it has one column makes it a column matrix. In order for a matrix to be a column matrix, it just needs to have one column. Let's look at example 2. What about this one? Very straightforward. Again, it just has one column. So this would be a 3 by 1. So the number of rows is irrelevant. As long as it has one column, then it's classified as a column matrix. Quickly. Next one. Let's look at a square matrix. Now, in order for a matrix to be a square matrix, the number of rows it has must equal the number of columns it has. So, for example, if we have now notice we have one row, 2 rows, 3 rows. And also we have one column here, 2 columns, 3 columns. So this is a 3 by 3. So this classifies as a square matrix simply because the number of rows here equals the number of columns. So once the numbers are the same, then it's a square matrix. Second example. Alright, so let's take a look at this one. There we go. So you can clearly see here that we have 2 rows and 2 columns. So this classifies as a square matrix as well. So once the number of rows equals the number of columns, then it would classify as a square matrix. Now, there are two other matrices that I'm going to mention, but I'm not going to show you the examples simply because we're going to buck up on these guys a little later in the topic. We're going to encounter them. So I'm not going to give examples of these. I'm just going to mention them. So 4 would be non-singular matrix. As a matter of fact, 3 more. So non-singular matrix and singular matrix. Those two matrices are going to be mentioned again the deeper we go down into this topic. And lastly, the identity matrix. Now these two we're gonna get to a little later in the topic, but this one here, the identity matrix, the letter I is normally reserved for the identity matrix, and this is a special 2 by 2 matrix where the elements are 1, 0, 0, 1. So this is classified as the identity matrix, and we reserve the letter I for that. Now this matrix here acts like the number 1, and you're not going to understand that now, but when we get further into the topic and we come back to this guy, then you're going to understand what I'm saying. So non-singular matrix, singular matrix, those two are going to be mentioned later on in the topic. And identity matrix is the letter I is reserved for this matrix, and the elements are 1, 0, 0, 1 in that specific pattern or arrangement. So those are matrices that we're going to see again later on in the topic. But just to recap, types of matrices. A row matrix is when we have a matrix with just one row, and those are the examples. So once a matrix has one row, it doesn't matter how many columns it has. Once it has one row, then it's classified simply as a row matrix. Column matrices. Once a matrix is classified as a column matrix, it has one column. The number of rows is irrelevant. As long as it has one column, it's classified as a column matrix. Square matrices. For a matrix to be classified as a square matrix, the number of rows must equal the number of columns. So once these two numbers are the same, automatically it's called a square matrix. And of course, non-singular matrix, I didn't give an example of that. Neither did I give an example of a singular matrix because I'm going to reserve these two for a little later down in the topic, and you're going to come across those again. And of course, the identity matrix, very important matrix. You're not going to see the importance of this matrix until later down. And the letter I is reserved for that matrix, and the elements are specifically and in this order and arrangement: 1, 0, 0, 1. So this is a special matrix where 1 comes here, 0 comes here, 0 comes here, and 1 comes here. Any other arrangement than that, it wouldn't be classified as identity matrix. So for example, if this were 0 and this were 1 and this were 0 and this were, no, that wouldn't be the identity matrix. This specific matrix is referred to as the identity matrix. All right. I hope you guys found this video insightful, and I'll see you on the next video.